So we're going to continue talking about some more recent models of visually grounded learning of spoken language. So the main challenge here that we're facing is scaling the data sets and the models up. So work from early 2000s, as we saw, was groundbreaking in the sense that it was introducing the new paradigm of learning language, but it was small scale. We saw that the number of objects and the number of words they were in, like maybe 20 or so in the very small range. Applying modern neural methods typically requires somewhat larger data sets than what these approaches were working with. And so the first issue here is the issue of data. And I'm going to talk a little bit about some of the data sets that have been becoming available over the last few years. So the first sizable corpus that became available was collected by David Harvath in 2015. It's known as the MIT Flickr audio caption corpus, and it's based on an existing image captioning corpus. So there is this whole area, this whole task, NLP task called image captioning or image description that consists in the task of a system being given an image is supposed to generate a written description of what can be seen. And so a number of data sets have been created for this task, and many of these data sets have then been adapted or modified for the visual grounding scenario. So the first such data sets came about in 2010 in a paper by Rush Chian and colleagues. It's known as Flickr 8K. 8K stands for 8,000 images, and each of these 8,000 images is captioned by 5 different annotators. These annotators are crowd workers, which are shown an image and are asked to make up a brief description of what they see. The images come from an image hosting service called Flickr, and that's also why it's called Flickr 8K. So you can see that from this example here, we have a picture someone took in a park of a woman with a frisbee and a dog, and so then people just write simple descriptions of what's happening there, such as a young lady is playing frisbee with her dog, or a woman is playing a frisbee with a dog, and so on. So you can see that this data set is in many ways less noisy than what we would expect from a natural setting of that language learners and children specifically face when trying to figure out language. There are some objects in the picture. The salient objects are very likely to be also mentioned in the caption, in the written caption. But anyway, this is a good approximation and a simplification of the setup that we're interested in, and so we'll be working with these type of data sets mostly for now. And so that was these were the written captions. What Harvath and colleagues did, they simply used these images and these captions and simply ask crowd workers to read the captions aloud. So a caption was shown, the written caption was shown to a crowd worker. The image was not shown. They were just simply asked to read that aloud and record it, and there was some quality issues which were solved by filtering the recordings, keeping only those where the ASR was able to recover most of the original caption. And so this data set is relatively small in terms of what we typically work with, and in something like ASR. So this is about 46 hours of speech. It's a much larger scale than what we saw with with these two previous papers from the early part of the century, but still by the standards of modern machine learning neural approaches, neural networks applied to something like ASR. It's quite small. Then there is another dataset for captioning. This is known as COCO, which stands for Common Objects in Context. This is a larger dataset. There are 3,000 images, and there are 5 captions for each of those again. These were originally written captions, and there's a number of datasets which were created based on this and which try to enrich it in some way and adapt it for the spoken language scenario. So 2 of them were relied on using synthetic speech and simply passing the original captions through a voice synthesizer in order to generate some kind of approximation of spoken captions. So myself with colleagues did one of those. We did something very simple. We used a single voice, relatively natural sounding. It's not a very robotic voice. We used Google Voice Synthesizer via web service. But it's there is no variability there in terms of speed. There are no disfluencies, and there's only a single voice. Havard and colleagues in the same year also did something very similar. However, they put a little bit more work into it. They used 8 different voices. They added some artificial disfluencies, and they added some variations in terms of tempo. And so I'm mentioning these data sets because there are a couple of papers which use them. However, they have been basically superseded by this most recent data set called Spoken Coco by Xu et al. From last year. And in here, the original written COCO captions were read aloud by crowd workers. So this is something like Flickr 8K, but the same methodology as used in Flickr 8K, but applied to this much larger data set. And in here we have about 6,000 captions. I will not actually mention any in any detail any work based on this data set because this is very recent. But just mentioning it here for completeness. And another data set, image data set, which has been the base of for creating a data set of spoken captions is called Places, the scene recognition database. There are two separate data sets with audio captions, both created by David Harvath and his collaborators. And they're in 2 different languages. So the first one from 2016 is our English captions. They're spontaneously spoken. So these are the way this data was collected. That the image was shown to a crowd worker, and they were asked to just spontaneously describe what they see and record it. And so this is quite different from these written captions. Written captions typically are shorter, cleaner, more to the point. In here, a person is faced with an image, and they just have to say what they see, and sometimes they just not very sure, or just they change their mind in the middle. So some of them can be kind of rambling and long. Some of them can be brief and similar to written captions. But an important point here is that we don't actually have the written version of the caption as such. So this is a data set which makes some types of analyses a little bit difficult because we only have the actual audio. We don't actually know like what the written version of that is. And there is a similar data set collected in Hindi a couple years after the first one was done. It's a bit smaller, but they are both pretty big.